Great. So today we'll talk about patching high-impact vulnerabilities. I don't know if you are acquainted with this WebP vulnerability that came out by the last quarter of last year, September. And, well, before actually talking about the vulnerability, I'm going to tell you who I am. I'm leading the application analysis team at Zimperium. I'm also an adjunct professor at UC3M Madrid. I'm the author of Fuzzing Against the Machine, which is a book on fuzzing vulnerability research. And what I normally do daily, I deal with all these very, very nice standards that help you guys to develop safe applications. So what we try to do in my team is actually deal with this and try to give you some solutions to cope with it. So what I'm going to show you is basically that it's very hard to patch things. And it's so hard that even to reach 50% of the population, it's a problem. And indeed, as of today, we haven't reached that for WebP. So this is so difficult that basically it can resemble an open heart surgery. And why I'm saying this is that you need to think that everyone has a device right now, and it's very likely you have a vulnerable application in your device. Me too, of course. Because on average, we have from 60 to 80 applications, and by the way, we have more than one device. So yes, it's very easy to have at least one application. And actually, I'm going to be even more vertical. Right now, you have a vulnerable application with the WebP vulnerability, because that's the deal of this talk. So yeah, that's the idea. So if you haven't seen the news, if you don't know about the vulnerability, basically this vulnerability was hitting the entire software stack. LibreOffice, Chrome, Firefox, and then they started to say that it was actively exploited in the wild. Then they actually said that it was starting with web applications, and then finally it was also discovered within Flutter, within the shared object of native code in Android, so all over the place, even in iOS. So then that's another thing, you know, and it got the highest possible score because it's a remotely exploitable vulnerability. So let's actually tell you how this process works, okay? This is the more academic version of the explanation of a patching process, but I have a simple solution for this. So before the patch is released and there is a vulnerability, you are kind of, you don't know what is going to happen. Then when you have the patch, you feel empowered, so you feel a little bit like this, you know? But the problem that I see into this is that in reality, what happens is that when you have the patch, you don't know what the population will do with this patch. You don't know what the developer will choose, if they will update, if there are some internal policies, external policies, you don't know. So in the end, you have something like this, which is the reality as of today, and then every one of these has their own policies and their own way to work around. So everyone will be and will have their own destiny, you know? So that's a little bit the state of the art right now. This talk is especially focused on Flutter because Flutter right now is becoming very popular. There are almost 1 million applications with Flutter around, and what it gives you is the possibility to have almost a single code base for multi-platforms. But now the deal here is, well, okay, you have this nice thing, single code base, one maintainer, it can work on both platforms, but well, if it has a vulnerability, it's very likely it will have the vulnerability on both platforms. So you actually deduplicated the coding issues and you duplicated the security issue. So that's a kind of trade-off developers have to deal with. So then you'll get basically this thing all over the place because you're using a single code base. And when your code base fails, it will fail on all the platforms. So we will analyze this CVE 2023. And the idea is that someone is going to ship an image to you, because WebP is an image format, and you get it on your device. So Flutter is multi-device, name it, you have it, okay? This is going actually to work lower level in your system and implement a technique which is very old, which is called buffer overrun. This happens on the heap. Well, the result of this is that someone will be capable of becoming root of your phone. One way or another, this could be a very nice vector to actually introduce something extra, some good and juicy payload in your device. Of course, this doesn't happen on a single device, but on many devices. And the reason is that the vulnerability is actually on everyone's phone. And that's something that I always say, is that everyone in this world, no matter his position in the society, will buy a phone that is like on a store which everyone have access to, because it's very difficult technologically to develop a mobile stack from scratch. So everyone will have either an Apple or a Samsung or something that which is, very on steroids, but nonetheless, it will be something that you can buy too. So everyone is exposed to the same thing. So the result, the potential result of wrong patching or patching managed in the wrong way is basically getting to this point, right? Massive exploitation, which is something that, thank God, on mobile devices is very well avoided. But if you remember a few years ago on computers, there were campaigns when everyone was actually getting the same virus. So we are not at this stage, thank God, but patching is difficult. So you're still exposed. Maybe the effort to getting into your phone is very expensive, so no one is trying to do it for every one of us. That doesn't mean we are safe. So let me actually explain you what we're actually going to see. In September, Citizen Lab, which is a very famous firm that does research on spyware and citizen freedom, said that this vulnerability was actually actively exploited and in iOS. That was the first point. Okay, then on 12th of September, they basically made it public, and the patch came right after. So this thing was actually well known, and they basically patched it right away. Now, the good and the big brands, they were reactive. What I mean is that in a matter of 1 month, everything was patched. Now, the issue is that if we have 80 applications on average on our phone, we don't only have top applications. You'll have all kinds of applications, and that's where the vulnerability may get you. So what actually we have done is, well, the idea is now if the top brands have patched, everyone is safe. Okay, back to contemplation, we are good. But in reality, what I said, that's what stands, You have apps that are not in the top brands. You have apps that you install because you have a specific need, and you just pick one from the store. So we got a sample of applications in 2023, and there is a number which may seem small. 1% is Flutter, okay? So we concentrated on this. Now, on this 1%, 90% was vulnerable, which is a huge number. So out of a sample of, 1 million application, 1% starts to be a significant number. Now, this happened after 2 months. Now we are at 6 months after the patch release. So we resample another random sample of application, and the stability of the number is there. 1% is Flutter. Now, 60% is vulnerable. So after 6 months, now it's 6 months, 5 months, when I did the last measure, 60% was still vulnerable, which actually makes happen that very likely 1 into 2 has a vulnerable application. And if you are more than one device, then the game is over. Now there is also a more interesting trend, which is, what about Flutter only? If I take another distribution of the data, like by looking at Flutter only applications, well, this is a funny thing. 10% of the application were vulnerable before the end of the year, and 15% are vulnerable after. And the reason why this is happening is that Flutter is becoming more predominant. There was an increase of 30% of Flutter adoption. So what happens now? Well, the hypothesis is I'm starting into Flutter, and I get a tutorial, and I get the wrong version, which is unpatched. Or I'm doing good. I go to the page, I download the latest version, and my toolchain doesn't work. So I go back, and I say, yeah, I have to use this one. It will work, fine, and it works. Then you release the application, vulnerable. That's it. So now, the idea that I actually told you is actually confirmed by this data. So there was this analysis that on average, we have something like in North America, almost 14 devices connection per person, okay? Plus, the destiny basically will be something like this, okay? You'll have all of these devices, so the number of applications that you have, more or less, it's 80, so you can easily understand how simple it is to get actually in trouble. And as a developer, you actually should take care of this at the source level. What I mean is that Flutter comes, the old version comes with something that is vulnerable by default, and anyone has time to actually read all the source code and detect this. So that's why there are solutions basically to solve these issues. Okay, so what do? How do we solve this issue? As I said, it's very likely you have something in here. The idea is, let's try to find a way to actually cope with this issue, to actually reduce the surface. How could you actually sort it out? The key is information and knowledge. So there is a friction between the developer and the user. Okay? The end user is the one that will be exposed, and the developer is the one that needs information to actually do the job of developing an application. So what happens is, how the developer is able to get all this knowledge about what is critical, what is not critical, and now actually he's able to make the right choice. You know, patching a code base may mean for a developer, I don't know, 2 or 3 weeks of stopping the activity because they need to actually fix this. So you need actually to structure your work in such a way that seamlessly you can recognize these things. So if you think about my first slide, that's where the standards come into place. If you actually try to stick to the standards, you'll have high chances to be less exposed. So yeah, of course, that's the idea that I've been trying to transmit during the talk. So you can only rely on patches and thinking that you are safe, because when the patch is released, it's very likely that someone has been exploiting this vulnerability for months. The patch is just something that has been found proactively, or there was someone that decided to step on someone else and reported the vulnerability. But in reality, vulnerabilities are used actually to spy on people. So they are very precious weapons. That is why everyone is looking for vulnerabilities to patch as fast as possible or to spy as fast as possible. So everyone that develops an application is a potential vector of injection. So we need to raise the awareness and say, okay, there is not only patching into this, because if we wait for the patch, well, the destiny is already done, you know. The exploits that had to be done were already done when the patch is out. So you actually need to look at the system and try to detect anomalies, for example. So you need a proactive system that try to understand if there is something weird happening in your system before. So by analyzing the code, using best practices, standards, that's how you can actually reduce the surface. This doesn't mean you will be completely protected from WebP, but you will actually increase the difficulty to exploit the vulnerability. In the end, what happens is that your chain is as powerful as your weakest ring. So you need to actually be careful when you do a development of an application, which choices you make, because the weakest ring is the one that will be used to actually develop an exploit. And our devices have a huge exposure by sensors cameras, microphones. So you name it, you have it. So basically, when you're actually developing an application and you're making sure that everything is covered, this is becoming very, very difficult even to describe for a human being. It's more than 35 things. How can you remember everything? So you need to be very careful, right? So now we are in the scenario where we are selecting an application, a random application, free PDF, QR, ebook, music, whatever, that's not in the top brands. You get it, and you have this kind of device, right? So that's exactly what I'm trying to transmit. Be careful what you do with your code, because it's very easy. You just inherit an SDK or something that you are using, and you don't know exactly what it does. So yeah, that's how we try to fix it, because the idea is, okay, as I said, there is a friction between these two sides of the application part. So you need something that actually is watching on you and actually helping you to develop somehow a solution that is stronger against these kind of threats. So that's actually how I summarize this into experience, intelligence, and outreach. This is actually based on a lot of years of iterations and people that have decided to dedicate their life to this. You know, it's like you are doing your app, this app is doing a specific thing. In our case, what we do is we are actually working to reduce the attack surface as much as possible. So ideally, you should actually divide your development cycle into 3 different scenarios and try to cope with all these 3 scenarios, because what you want to do is actually be sure to reduce the attack surface as much as possible. And so we are close to conclude the talk, and what I want to say is, as a company, we actually do this especially tailored from source code to your APK. We have solutions for this, and that's actually our daily work based on all the standards and all the best practices that are out there. So visit us at the booth on the first floor if you are interested, and thank you very much for listening to my talk.